Hey everyone and welcome back. Today we're going to be doing a deep dive into something pretty crazy.
Oh yeah, this one's wild.
So it's all about space junk.
Lots of it up there.
But the thing is, the thing that makes this so interesting is we're talking about how climate change is actually impacting space junk.
Yeah.
And we have this article here from MIT News
MIT always doing cool stuff.
called "The Sky is Falling." And it's leaving space junk stuck in orbit.
Catchy title.
Right. This is from March 17th, 2025.
Very recent.
And basically, MIT aerospace engineers did this new research and found that greenhouse gases, the things that cause climate change, are actually causing the upper atmosphere to shrink.
Yeah, they're shrinking the thermosphere.
So let's get into it.
Let's do it.
So first of all, what is the thermosphere?
Well, think about where satellites orbit.
Okay.
That's basically the thermosphere.
Okay, so that's where all the satellites hang out.
Yeah, pretty much.
Yeah.
And so because of the increase in greenhouse gases, it's actually causing that layer to contract.
Wait a second.
Yeah.
So greenhouse gases, they trap heat,
Right?
and that leads to a warmer planet.
Uh-huh.
But you're saying they're causing cooling and shrinking somewhere?
Well, yeah, it seems counterintuitive, right? So down here, lower atmosphere, yeah, it's trapping the heat, global warming.
Okay.
But up in the thermosphere, totally different effect. It radiates that heat away into space.
Oh, wow. So it's like opposite.
Yeah, it's like this weird cosmic balancing act, but there are some consequences.
Yeah, so down here getting hotter and hotter, but up there?
Up there, it's getting colder and smaller.
That's crazy.
It's actually happening. Like, we have the data.
Oh, really?
Scientists have been looking at the drag on satellites.
Okay.
And over the past decade, it's showing very clearly that the thermosphere is shrinking.
So the sky is falling just very, very slowly.
You got it.
But, okay, so less space up there.
Right.
What's the big deal?
Well, you've got to think about how we clean up space junk naturally.
Okay.
That's atmospheric drag. It pulls those old satellites, debris, all that stuff down to the lower atmosphere, and then it burns up.
So,
Safely re-enters.
okay.
But less drag,
Right.
more junk.
Oh, so it just stays up there.
It just stays up there.
Yeah.
And it's becoming a huge problem because low Earth orbit is so crowded these days.
I mean, we have launched a lot of stuff up there.
Oh, yeah.
But how much are we actually talking about?
So right now, over 10,000 satellites
Oh, wow.
in low Earth orbit, and it's only going to grow.
Yeah, I can imagine.
But it's not just the satellites themselves. It's all the little pieces, the things that come with them.
Right, all the parts.
Exactly. Spent rocket stages, fragments from old satellites.
Oh, wow.
Even little flecks of paint.
Really? Flecks of paint?
All that zipping around at super high speeds.
That just sounds dangerous.
It is. The more crowded it gets, the higher the chance of collisions.
Right.
And we're not talking fender benders here.
Right.
These collisions create even more debris, leading to what's called runaway instability.
Runaway instability.
Yeah. It's not a good thing.
I can imagine. What does that even mean?
So it's like a domino effect in space.
Okay.
One collision leads to more collisions,
Right.
creates this ever-expanding cloud of debris.
And that's not good.
No, it's not, because eventually certain orbital zones could become so full of debris that they're just unusable.
Wow. It's almost like we're creating a minefield in space.
Yeah, that's a good way to put it.
Okay, so we have this shrinking atmosphere, less drag,
Right.
more and more space junk.
Uh-huh.
How bad could it actually get?
Well, that's where the concept of carrying capacity comes in.
Okay, carrying capacity.
It's a term from ecology, actually.
Interesting.
Describes how many organisms an environment can sustain.
Okay, I see.
But it applies to space, too.
So, like, how many satellites can we actually fit up there?
That's exactly it. And this MIT study looked at that. They used simulations to model how the shrinking thermosphere is going to impact that carrying capacity of low Earth orbit.
Right.
It's not good news.
Oh, no.
Their simulations show that by 2100, the carrying capacity of low Earth orbit could be reduced by 50 to 66%.
Wow, that's huge.
It is.
So we're basically cutting the usable space in low Earth orbit in half,
That's what it's looking like
just because of climate change.
because of climate change. Yeah.
Wow. Okay, so imagine a highway,
Okay.
already packed with cars.
I'm with you.
Now you try to squeeze twice as many cars on that same highway?
Recipe for disaster.
Total disaster.
Yeah, and we're actually making it worse.
You're talking about the mega constellations.
Oh, yeah.
Like Starlink,
SpaceX.
thousands of satellites,
All going up
the
there.
global internet coverage.
Yeah, they're adding a whole new layer of complexity.
So it's like we're launching more satellites
Yeah.
while simultaneously shrinking the space available to them.
It is a little ironic, isn't it?
It really is. It's
Yeah.
like we didn't think this through.
Yeah, it's a classic case of unintended consequences. Our actions here on Earth, particularly greenhouse gas emissions, are impacting the sustainability of space operations.
It's like everything we do down here impacts space.
That's exactly right. We're all connected.
It's kind of scary to think about all that, you know?
Yeah, it's a lot.
What can we even do about this whole situation?
Well, it's a big challenge for sure, but it's not hopeless.
Okay, good.
There are actually people working on this, trying to find solutions.
Okay, well, that's good to hear.
One thing they're looking at is improving space situational awareness.
Space situational awareness.
Yeah, basically it means having a really good understanding of what's going on up there.
Okay,
So like air traffic control, but for space.
okay, I get it.
If we can track everything really well, like all the satellites, all the debris,
Even those little flecks of paint.
even those, then we can maybe predict collisions better.
Okay, so we can move stuff out of the way.
Exactly.
But how is that even possible? I mean, there's so much stuff up there, and it's all moving so fast.
It's true. It's a lot to keep track of, but technology has come a long way.
Okay.
We're seeing some amazing new radar systems and telescopes that can detect even tiny pieces of debris.
Oh, wow.
So we're getting better at seeing what's out there.
Okay, so that helps us avoid collisions, but what about all the junk that's already up there?
Right, good question.
Can we actually clean up space?
Well, a giant space vacuum cleaner would be pretty cool.
That would be amazing.
But in reality, it's a bit more complicated than that.
Okay.
But there's some really interesting solutions in development.
Okay, like what?
Well, one idea is to use robotic arms or nets
Oh, yeah.
to actually capture the larger pieces of space junk.
Oh, wow.
And then you can either guide them back into the atmosphere to burn up
Oh, yeah.
or move them to a graveyard orbit further away from active satellites.
Oh, so park them somewhere else.
Basically, yeah, just get them out of the way.
Okay, so that's for the big stuff, but what about all those little pieces?
Yeah, the smaller debris is trickier,
Yeah.
but they're looking at things like lasers.
Lasers.
Yeah, powerful lasers that could vaporize small pieces of debris.
Hold on.
Yeah.
Lasers in space.
It sounds like science fiction,
It does.
but it could be a real solution.
Wow. But are we actually close to being able to do any of this stuff?
Some of these technologies are closer than you might think.
Really?
Yeah, there have already been some successful demonstrations of debris removal.
Oh, wow.
The challenge now is figuring out how to do it on a larger scale.
Right, because there's just so much stuff up there.
Exactly.
This sounds like it's going to take a massive global effort.
It will. This isn't something any one country can solve on its own.
Yeah. We all need to work together.
We do. We need international cooperation, shared resources, expertise,
Yeah.
and we definitely need to agree on some rules and regulations.
Oh, yeah. I could see how that would be important.
It's essential.
So it's not just about cleaning up the mess we've made.
Right.
We also have to address the root cause of the problem in the first place.
Absolutely. We can't forget about climate change.
Yeah.
If we want to keep using space sustainably,
Uh-huh.
we have to get serious about reducing greenhouse gas emissions.
Because that's what's causing the thermosphere to shrink.
Exactly.
Okay, so even if we do all that clean up the space junk, tackle climate change,
Yeah,
there's still a limited amount of space up there.
that's true.
How do we even decide who gets to use it?
That's the big question, isn't it?
Yeah, who gets to decide which satellites get to stay up there?
Well, this MIT article suggests that we need to start thinking about orbital space differently.
Okay, how so?
Maybe it's time to consider space as a shared global commons,
Oh, interesting.
like our oceans or the atmosphere.
Okay.
It's not just a free-for-all,
Right.
It's a resource that needs to be managed carefully.
Sustainable.
Right, well-
So like we do with environmental protection. We need to apply those same principles to space.
We do. We have to stop thinking of space as this infinite frontier that we can just exploit.
Right.
It's not infinite.
Yeah. And it's definitely not just ours for the taking.
It's a shared resource.
So if we want to make sure it stays viable for the long term,
We need rules.
rules and regulations, yeah.
Yeah.
Okay, I can see that. But how do we even begin to do that?
Yeah.
How do we decide who gets access to this limited space?
Yeah.
What are the criteria?
That's where things get really complicated.
Yeah,
There are a lot of factors to consider,
I bet.
and there are no easy answers.
Okay, well, what does the article suggest?
Well, they propose some interesting starting points.
Okay, I'm listening.
One thing they talk about is the purpose of the satellite.
Okay, the purpose.
Yeah.
So, like, what is it actually doing up there?
Right. Is it providing some essential service,
Okay.
like communication or navigation?
Okay, so those would be high priority.
Right. Or is it mainly for commercial purposes?
Okay.
Like Earth observation or even space tourism?
So we'd prioritize the essential stuff over The maybe less essential stuff.
That's the idea.
Okay, that makes sense. But what about all the scientific research satellites?
That's a good point.
I mean, they might not be doing those everyday services,
Right.
but they're super important for understanding the universe.
They are essential for advancing our knowledge.
Yeah, so where do they fit in?
Well, maybe we could have designated orbital slots specifically for scientific missions.
Oh, that's a good idea.
Sort of like zoning laws, but for space.
I like it.
So we can make sure that research is protected.
Okay, but even within those categories, you're going to have tons of satellites all wanting those spots.
That's so true.
So how do you choose?
That's where it gets even more complicated.
Yeah.
We might have to look at things like the lifespan of the satellite.
Okay, how long is it going to be up there?
Exactly.
Okay.
And its size.
Okay.
And its potential to create more debris.
So we're basically saying if you design a satellite that's smaller, shorter-lived, and deorbits itself at the end of its mission,
You get priority.
that can make sense.
So we're encouraging responsible design.
Yeah.
And responsible operation.
Okay, so there's a lot to think about
A
here.
lot to think about.
Which brings me to another big question.
Okay.
Who actually gets to make these decisions?
Right.
Is it up to each country to decide for themselves? Or do we need some sort of international governing body?
Yeah, like a global referee for space.
Exactly. Yeah, a global referee for space. That sounds like a good idea.
It does, doesn't it?
But is that even possible? I mean, to get every country to agree on something this complex, it just seems...
Oh, it would be a huge challenge.
Yes.
But this MIT article, they bring up the idea of a United Nations of space.
A United Nations of Space.
Yeah.
Wow. Okay, so a governing body?
That could set regulations, guidelines.
Oh, everyone?
For the whole world, yeah.
That's a pretty powerful concept.
It is.
I imagine there would be a lot of obstacles to actually setting something like that up.
There would be a lot of hurdles, but think about what could happen if we don't.
Okay, what do you mean?
Well, without any kind of global governance,
Uh-huh.
it could become a free-for-all up there.
Yeah, just chaos.
Total chaos. Countries launching satellites with no regard for anyone else,
Right.
creating even more debris,
Yeah,
making it even more dangerous.
and we rely on satellites for so much these days.
We do. It's not just about space exploration anymore. It's communication, navigation.
Weather forecasting.
It affects our everyday lives.
even national security.
Exactly.
We really need to protect that.
We do.
It's almost like we need to change the way we think about space.
I think so, too.
Instead of seeing it as something to conquer,
Right.
we need to treat it like a shared resource
Something we have to manage carefully
for everyone.
for the benefit of all humankind.
Yeah, I like that.
This isn't just about preventing a space junk catastrophe.
Right.
It's about making sure that space remains a place of opportunity
For discovery.
for future generations.
Yeah, that's a really good point.
It's about our future.
Wow. This deep dive has been so interesting.
It has.
We've learned about this crazy connection between climate change and space junk. We've talked about potential solutions.
Lasers, space nets.
Yeah, and we even got into the idea of a United Nations of space.
It's been a wild ride.
It has. So what are your final thoughts on all of this?
Right.
What should we take away from this conversation?
Well, the challenges we're facing with space junk and climate change are definitely serious, but they're not insurmountable.
So there is hope.
There is. We have the knowledge, we have the technology,
Yeah.
and I think we have the capacity to work together
Find solutions.
to make sure space is sustainable.
Yeah.
But it's going to require a shift in our thinking.
Right.
We have to start recognizing that what we do down here on Earth
Uh-huh.
affects space.
Right. Everything is connected.
It is. And we need to find solutions that benefit everyone,
Not just a few countries.
not just a few companies.
Everyone.
Yeah. The whole world.
I love that. Well, thank you so much for joining us for this deep dive. It's been an amazing conversation.
It's been my pleasure.
And I'm so glad we could explore all of these ideas together.
Me too.
And for everyone listening, thank you for tuning in. And we'll catch you next time for another deep dive into the world around us.
See you then.